Hi, in this series of videos we're going to be looking at GCSE Maths walkthrough. Each of the playlists is going to be about 4 or 5 videos. Each video will be about 20 minutes long. Please do stop the video, have a go at each of the questions and then compare your solutions. If you do need any help, please add a comment below. I'll always come back to you. I look forward to seeing you inside the next video. Hi, this is the third video in the playlist where we're looking at the AQA, and it's the higher tier paper 2 from June 2018. In the previous video we completed through to question number 18, so we're going to start today from question number 19. If you're not sure, please do add something in a comment below. I'll always come back to you. Okay, these questions are more challenging, so it would be good if you do, as I mentioned before, work through each of these and then compare your solutions. Okay, so pentagon is made from a square and, importantly, an isosceles triangle. So what that means is, if it's isosceles, then this length and this length, as they've noticed, is exactly the same. Okay, but it also, because it's an isosceles triangle, it means actually it's made up of 2 right angle triangles, and I can use that information to be able to figure out the slope length, which is this length, because the actual question is asking us to work out the perimeter of the whole pentagon. Okay, so let's have a look and just concentrate for the moment on this particular right angle triangles. So what we've got is a right angle triangle like that. And what we know about it is that this angle here is actually going to be 35 degrees. Now, the reason it is because this angle here is 90. And then you've got 125 overall. Take away 90 means that this will be 35 degrees. Okay, what we also know is that the length along here is actually going to be 6. Now again, the reason we know that is because this is halfway between this point and this point, so overall that's 12, so halfway must be 6. Okay, so we're now in a position where we can use either SohCahToa or TOA to be able to work out these particular solutions. Well, the one I'm going to choose is going to be the cosine rule. Now, the reason that is because I know the adjacent. Remember, this is the opposite. I know the adjacent, and I need to know the hypotenuse, which is this length along here. Okay, when I've got that, I'm just going to double it, and then I'm going to add to the perimeter of the square, and hopefully we should be good to go. All right, so let's have a look at this application. So I've got the cosine of 35 degrees equals the adjacent, which we know is 6, divided by the hypotenuse. Okay, now you need to use a little bit of manipulation here, and again, you might be slightly differently to the way that I do it. I need to get the hypotenuse equal to something. Okay, so if I do both sides multiplied by h, I get h cosine 35 equals 6. That's fine by me. And then I'm going to divide by cosine 35. So I can write that the hypotenuse is equal to 6 divided by cosine of 35 degrees. And if I pop that in my calculator, what I'm going to end up with is going to be 7.32464. All right. So in other words, what we're saying is the length of this particular part of the pentagon is going to be 7.32464 centimeters. Okay, so the perimeter then, it's just really a case of adding everything up. So what I've got is going to be the perimeter is going to be 7.32464, and I think that's sufficient in terms of the number of decimal places, multiplied by 2. Okay, and then I'm going to add it to 12 plus 12 plus 12, which is 36. If I add that to 36, what I'm going to get is something like 50. 649295507. Okay, yes, of course, you don't need to write so many decimal places, but if you do, it just kind of impresses upon the examiner that when you've got the actual answer to say something like 2 decimal places, that you've based it on a full calculation. Okay, I hope that's okay for you. Let's move on then to question number 20, which again, just a little bit of an application of the information that we've got. Okay, and fairly typically it's actually being written in a little bit more of a difficult way than the actual question itself warrants. Okay. All right, because what we've got here is actually values of A and values of B, and all we're doing or being asked to do is plug it into this formula. Okay, so we don't really need to know particularly it's the volume of a ring. If you want to, it's perfectly fine, but this is a way in which they've chosen to calculate the volume, and we've been very nicely already been given A and B. So if I work that out by simply substituting the numbers, then I'm going to get the volume equals, and I've got 0.25 pi squared. Okay, well that's fine, we can put that in a calculator, not a problem. And then I've got B minus A, well that's going to be 30 minus 20 squared. Okay, and then I've got B plus A, which is going to be 30 plus 20. Now the reason this is a 3-mark question, apart from kind of understanding it, is you've got to be a little bit careful about your application in a calculator. A lot of calculators now are a bit more sophisticated, but you've got to remember BIDMAS always. So the bit that you're interested in is always making sure that you follow BIDMAS. So this particular bit of it, 0.25 pi squared, you can put that into a calculator and work it out as a decimal if you wanted to. But this is going to be 30 minus 20, so that's going to be 10. Okay, because you always do what's in the brackets first. So this is going to be multiplied by 10 squared, which is 100, and then multiplied by 50, and those little dots just mean multiply. Okay, so when you've worked your way through all of that, hopefully you'll get something like 12337.0055. Okay, now the actual answer to the question is asking us to put it into 3 significant figures. So what we do is we look at the third significant figure, which is 3, and then we ask, do we need to change it? Well, no we don't, because the number after it is less than 5. However, we do have to maintain the place value. So remember, this is 12,337. So it's going to be 12,300, and that's 2, 3 sig fig. Okay, hope that's all right for you and you were able to follow that without too much of a problem. It just looks a little bit complicated until you plug in, or realize it's just plugging in the numbers. Okay, so let's have a look then at question number 21. Now 21 is another formula that you need to remember, which is called the cosine rule. Okay, so I'm not entirely sure on AQA whether this is at the front of the exam paper. It certainly used to be, and I know it is with GCSE, but I've got a feeling it's not on the papers anymore. I'm really sorry. Okay, so you need to kind of remember the formula, and the formula is going to be a squared equals b squared plus c squared minus 2bc cosine A. Now the reason I've written that down is so that I can use all of this to plug in the information I need to show how far Tia is walking to the shop. So I need to know how far this particular length is. Okay, because don't forget the diagram is showing their position at 2 o'clock. Okay, so let's see if we can kind of figure out assuming that they're walking at the same speed, I know that Liz is doing 80 metres, and I need to know if this is more or less than 80 metres. Okay, so looking at the diagram, I've got A is this angle here, capital A, so it's the cosine of 75 degrees. And in this particular case, it's a rule that you need to know the inclusive information. So in this particular case, I'm going to say B is 60 and C is going to be 80. Now, if I just put that information into the formula, I should be able to work out how far Tia walks. Okay, so it's going to be A squared equals B squared plus C squared minus 2BC cosine A. I know I've written it down already. I'm going to write it down again because, again, another little sort of comment here is that the more you write these formulas, the more you'll remember them. Okay, so B squared is going to be 60 squared plus 80 squared minus 2. I'm going to use a dot again. B is going to be 60 dot. C is going to be 80, okay, and then I've got multiplied by the cosine of 75 degrees. Okay, pop all of that in the calculator. Now, be really, really careful to make sure that the calculator does the calculation that you want it to do. So 60 squared plus 80 squared, I actually tend to separate these type of calculations out. So I'm looking at my notes here, 60 squared plus 80 squared is actually 10,000. I'm going to minus this calculation, which is going to be 2484.66. Okay, so that gives you the value of A squared is that takeaway. That is going to be 7515.337, and if I square root it, I know that Tia is going to walk 86.69 meters, which is Tia to the shop. Okay, all right, so actually she's going to arrive a little bit later than Liz is, because Liz is only going to walk 80 meters and they're both walking at the same speed. So my answer to this particular question was Liz will arrive first. Okay, right, then it says, in fact, Liz walks at a faster speed than Zia. How does this affect the answer? Well, it doesn't matter, because Liz is going to arrive first anyway, so I would put something like Liz will still arrive first. Okay, and I could put something like possibly earlier if you really want to, because she's walking at a faster speed, so she's going to get there a little bit sooner. Okay, let's have a look then at question number 22. So we are rattling through these. Please, as I mentioned before, do stop the video, have a go at each of these questions, and then compare your solutions. So we're about 12 minutes, I think, into the video, so we'll probably do a couple more of these. And then we'll take a break, and then we'll finish the final two or three questions. Okay, so a circle has a centre of 0 and passes through 5. Centre O passes through 5, 0. Okay, right. So it's got a centre there, and it's got a radius of 5. Well, one of the things you need to know is the equation of a circle is x squared plus y squared equals r squared. Now, in this particular case, the radius is 5, so therefore the one that would be correct would be the first one, because the radius squared, 5 squared, is equal to 25. Okay, so x squared plus y squared equals 25. Hope that's all right for you. Okay, let's have a look then at question number 23. Question number 23 is, again, a little bit more challenging, but hopefully you should be okay with it. So what I would generally tend to do with these sorts of things is do a little bit of a sketch first, okay? So I've got two solids, x and y, are similar, so it's similar volume, similar surface area. In other words, they've got a scale factor between the two. Okay, so let's have a look at what's happening. Well, I've got, let's say, x, I'm going to put it into a cylinder. Okay, this is cylinder X, okay, and then I've got cylinder Y. Now I'm going to make it bigger. Okay, it's not always the case in these particular questions, and my diagram isn't great, but it'll give you some idea of what's going on there, because X has a volume, so I can put volume is 64 centimeters cubed, and the volume is 343 centimeters cubed. It's not the greatest diagram in the world, but hopefully it'll give you some idea. Okay, the other thing is that I know the area of surface area of X is going to be 176 centimeters squared. Okay, work out the surface area of Y. All right, well, what we need to do really is firstly work out the actual scale factor. So this relationship between here and here is actually equal to K cubed. It's the scale factor cubed for a volume relationship. So if I want to work out the value of the actual K, I've got to cube root it. Okay, so the difference, or the multiplication between 64 and 343, I can work out, let's just find a bit of space here, I can work out as being, I'll do it down here, so K is going to equal, remember I said the cube root, and to work out how much I've multiplied 64 to get to 343, I could just simply divide it, okay? All right, now I hope you're okay. Again, there is a playlist on the website of on the channel of Mathematically Similar, and it will give you quite a lot of practice of these types of questions, okay? But if I work that out, it's going to give me very neatly 7/4. So I know that the linear scale factor is 7/4, okay, or if you like 1 3/4. So from a linear point of view, if this was 1, then this height would be 1 3/4, okay? So it's a length relationship. So if I were to find out the surface area of Y, I've got to multiply that by K squared, because the surface area is a K squared term. So all I'm going to do is I'm going to say the surface of surface of B, okay, or Y actually I should have put, but the surface of Y is going to be 176, which is the surface of A, multiplied by the scale factor squared, okay? Now, if I pop that into my calculator, I'm going to get 539. Okay, so that would be the answer to this particular question. The surface area of Y is going to be 539. I still keep getting that wrong, don't I? So that would be Y. Surface area of Y is going to be the surface area of X multiplied by the scale factor squared. Okay, hope that's all right for you. So let's have a look then. So at the moment, the next question is okay. It's not too bad. It's all about bounds. So I think we'll do that. Okay, we'll have a go at question number 24 and then we'll take a break. Please do have a look at all of these videos and do try to solve them for yourself. Okay, so let's have a look then at question number 24. And it says a tank is a cube, cuboid measuring that by that by that, and all the lengths are to the nearest centimetre. Now, as soon as you see that, it basically means bounds. Okay, now this is a 4-mark question, so you could, I guess, for 1 mark just have a go and you could pick, you know, the tank, the container, or the cannot tell, okay? But I think that they're after a little bit more working than that. So what I would do is I would say, well, actually, if I've got 50, so bearing in mind this is this tank I've got, it's something like that. Okay, not the greatest diagram, but let's say this is 50, the height is 20, and the depth is going to be 35. It's something like that, really. Okay, so 50, well, I've got the lower bound and I've got the upper bound. Okay, well, the lower bound of 50, correct to one decimal place, is going to be 49.5, and the upper bound is going to be 50.5. And again, have a look on the channel if you want some more information about bounds. Okay, so 35 is one of the other dimensions. The lowest is going to be 34.5, the upper is going to be 35.5, and then finally the final dimension is 20. Well, the lower bound is going to be 19.5 and the upper bound is going to be 20.5. Okay, and remember, bounds are equal distance. So this is a drop of 0.5 centimetre. This is an increase of 0.5 centimetre. Drop of 0.5 centimetre, increase, drop of 0.5, increase of 0.5 as well. Okay, let's now pop that into a formula to see if we can figure out the size of the tank at its maximum capacity and at its minimum capacity. Now remember also that they've given us 34 litres. Well, litres is exactly the same, 1 litre is exactly the same as 1,000 centimetres cubed. Okay, so actually the capacity of the container is going to be 34,000 centimetres cubed. Now let's go back to the tank itself. Now the tank, well, the upper bound of the tank is going to be this multiplied by this multiplied by this. It's going to be the area of 50.5 multiplied by 20.5, so this area here multiply the depth of 35. Okay, now I've written it slightly differently there, but the upper bound is going to be, the tank is going to be 50.5 times 35.5 times 20.5. Pop that in your calculator and you will get 36,751 0.375 centimetres cubed. Okay, so let's have a look then at going to be the lower bound. Well, the lower bound of the tank is going to be the lower bounds all multiplied together. So 49.5, 34.5, 19.5, pop that in your calculator and you'll get 33,301.125. So in other words, there's what, a 3,500 centimetre cubed difference between what the tank could be at its biggest and what it could be at its smallest. So actually we can't tell whether the tank has got a greater capacity than the container or it's got a smaller capacity than the container. We can't tell. It could be as low as that or it could be as high as that. Okay, I hope that's okay for you. I think we'll finish at this particular point, which means we'll start the video or the next video from question number 25 onwards. If you're not sure about anything, please do add a comment below. I'll always come back to you and I'll look forward to seeing you inside the next video.